next we have Forrest, who's a software engineer at Protocol Labs, leading the Lily project, which is a very fundamental project for getting Filecoin data. It's also a major data source that we as Starboard uses. So today he's gonna introduce Lily, the software that Protocol Labs use to monitor, extract, and also analyze the Filecoin network. Lots of the analytics that you saw today are actually built on top of Lily. So without further ado, welcome Forrest.
Hey there. Quick note on Lily. When the Filecoin network launched, we didn't exactly know how we were going to get the data. So shortly after the launch, we decided to create a version of Lily, and I'm going to talk about it here. It allows you to monitor the chain and rewalk the chain at any given point in time. Initially, we set out to answer a lot of questions. We didn't really know what questions we would need to answer, but we had an idea what some of them would be. I've described them here. RG, if you're around, I think we have a really similar slide, but coming at it from different angles. So an example, we need to be able to answer some things that are not on here, like who sent this message, who received this message, how many sectors were added in the last X days, or anything that really a user could come up with, essentially building both a relational database and a columnar database so that you can answer aggregates and then you can have relations. The list is basically endless, so we extract all the data we can continuously, and the amount of data on the network grows. And when I say data, I mean actor states, things like blocks, messages, receipts. And as the protocol grows, new actors are added. The verified registry actor was added that helps with Filecoin Plus. So this is a growing data set that we have to maintain and build as new state grows. Some use cases, once you have this, you can build really nice dashboards like Starboard. I have some of my own in here. I'm not very good at UX, so we should look at theirs. You can build notification systems. If the power in the network drops, it's important to know about that, and you can set up monitoring and alerting around that. You as a developer can spin up Lily on a test network, and you can deploy a change to it, and you can see the effects of that change in real time. It's really important when you want to validate your assumptions and validate the changes you're making. And for business intelligence, if you want to understand the return on investment, you could use software like this or the data the software collects to gain an understanding of that, and you can validate if there are areas in the market that you could take advantage of. So this is how we use Lily. Graphic design is my passion. Some of these graphs, it's alerting that we have internally. If the base fee rises, it's good to know that and good to go investigate why. And you can use this in conjunction with tools like the ones from Starboard to get an understanding of, one, this event happened, and then two, how do I go investigate this and how do I explore it, and who do I notify or how do I react to this type of situation. So Lily, quick bit on the naming. Everyone's probably, hopefully, heard of Lotus. Lotus is the Go implementation of Filecoin. Lily is basically a wrapper over that, and we named it Lily because, like the flowers, they're often confused with each other, but they are different. The point here is that Lily is essentially a Lotus node with a wrapper over the top of it. So an overview. It runs Lotus. You could start a Lotus node. You could kill a Lotus node. You could start a Lily node from that repo, and everything would behave as expected. But the differences now lie in that Lily can capture the messages on the chain, the blocks, the receipts, the actor states as they change. And it can capture other things like internal messages that don't necessarily appear on chain, but result from applying a message. There's state in that you need. An example of one of these would be a multisig transaction. You stage a message inside of a multisig actor, and at some point, signers approve that it should be sent, but that send doesn't appear on chain. Some distribution of tokens from miners happen this way, and it's useful to be able to track that. And right now, it's hard. Using these APIs, you can either watch the chain as it grows, because you want real-time data, or you can walk backwards in history, because you're running the software for the first time, and you want to gather this information. Once you've gathered it all, you have a variety of outputs you can use. You can put it into a SQL database, you could write it to CSV files, or coming soon, you could store it as IPLD data. Ultimately, a spec for something like this should be created, and it's something we're thinking about. There's a lot of people that solve this problem in a variety of ways, and it would be great if we outputted data in a common format that everyone could operate over. So I wasn't sure who I was presenting to. This is mostly data scientists, I gather, and others. This may be somewhat overly technical, but I think it's worth getting into because it kind of hits at the why this is hard, maybe why it's not as reliable as we wanted it to be, although major improvements have been made. I borrowed this from the IPLD team with their permission. It's somewhat of a view of what the chain looks like in IPLD, and Lily's job is to operate it over this data and find out what has changed at 2 different states or at a variety of states. And there's 2 paths. There's the fast path and there's the slow path. And Lily does both of these in parallel. On the fast end, it extracts blocks, messages, receipts, things I've said, implicit messages and VM messages. The FVM uses an actor model. It sends messages between the actors. These don't appear on chain, but they're triggered by messages that do appear on chain. And we need to gather all this information. There's also implicit messages. They're messages that apply with every block, and they just happen automatically. The block reward is an implicit message. Things like minor reward, minor penalty, and win count are tracked in that. There's also a cron actor that has an implicit message that occurs. We keep that information. Furthermore, there's things like circulating supply, distribution of tokens, vesting, how much of locked tokens have been unlocked, and Lily captures this, and it does this fairly quickly and preserves that information. On the other side, there is actors that have changed. Storage providers have sectors, and these sectors go through a variety of states. They get added to the network, they get proved over, sometimes they fault, sometimes they get recovered, and eventually they get terminated or expired. Lily captures this information with the goal of making it available for someone to build a reputation system over, or you could build alerting over it. The goal here is not what Lily does with it, it's that it makes it available for others to use. This ends up being a fairly lengthy process to get all of this done. It takes about 5 seconds to validate a block, and it takes about a second to hear about it. So now you have 20 seconds to do all of this. And if you can't do it in 20 seconds, you'll never be able to keep up with the chain as it grows. We ran into this problem fairly early on in the project, and we needed a way to mitigate it because you would miss data, and users of Lily wouldn't have the data they need, which led us to scaling Lily horizontally, and this is where we are today. When we run Lily in production, we run many nodes, and there's a node that watches the chain and puts information into the queue, and there's a variety of worker nodes that you can configure that do the processing work I was describing here. This has allowed us to scale Lily so that we no longer miss information. And for about the past 5 months, it's been reliably serving data that teams like Starboard and others have been using for their dashboards. I'd like to bring up David from the data team to talk a little bit about how we are using the data that Lily produces for our own insights.
Hi, I'm David from the data team. I'm going to talk more in the side of how we use Lily to get the information and power our internal dashboards. Basically, we don't have to run Lily in a distributed mode, so we rely on an ETL pipeline and lightweight snapshots to basically spin up a node, get the snapshot, load it into Lily, generate the CSVs, bring down the node, and save the CSVs into our data warehouse. So Lily is totally stateless on our end. And once the tables, the CSVs, are into our data warehouse, we add some modeling on top of that using dbt. And that looks like the lineage graph in the right side of the screen that you can look better here. So Lily will produce some denormalized tables, which we aggregate into more analytical friendly tables where we add metrics, new dimensions, and new columns. And yeah, that's mostly it in the terms of the data side. So if you have any question for me or for Forrest?
Yeah, I have a question for the Lily side. When actor, like if the FIP for actor events gets passed, how would Lily, would this mean that would Lily still have to diff the states, or could all of the data just be derived from the actor events?
Sorry, can you say that again? It was a little bit loud.
Sorry. Okay, let me see if I remember my question. So if the FIP for actor events gets passed,
I see. Yeah.
would you still have to diff the state tree and all of these other diffs, or could you just get the data from the actor events?
Okay, so unpacking that. FEVM is coming out, and as part of that spec in the EVM, there are a set of log messages that every smart contract, or as Filecoin calls them, actors, must produce that describes, it's not in the slides, that must describe what is happening at every state. EVM does this, and it's how block explorers in EVM gain context into what's occurring in the network. The question is when we add this to FEVM, well, we need to do the turtle. It's kind of unknown. It depends how these messages are added to actors, when they're added, and it basically puts it in a shrinking box. The responsibilities of the turtle are fairly large right now, and as more events describing the state of the network are added, the duty of it shrinks, and ultimately the turtle goes away and the software gets faster and more reliable, and we can get more granular information.
Thank you.
Hi. Super interesting. We will talk after this, but this runs not alongside the nodes, but somewhere else where you collect this information, or do you still deploy this whole architecture with a Redis, with the notifier, with the workers alongside a node?
By alongside the node, do you mean the Lotus node?
Yes.
So these Lily nodes, hard to describe, are Lotus nodes themselves.
All right. Okay.
So they are syncing the chain. You can publish messages. You can do anything you would do with a Lotus node, and you can do this fancy state diffing magic.
Cool. My second question is, there's this open source spec for metrics, logs, and traces called Open Telemetry. Is there something similar in the blockchain space, which would be amazing?
David, you know? I don't know of any. The closest thing that we have found so far is IPLD. You can define a schema for how an object ought to look, what fields it has, how to marshal them, how to unmarshal them, and then you can generate code to read and write that object. What we're leaning towards right now is emitting an IPLD structure that has each of the data models that Lily extracts in it, along with a schema that tells you how to read this data model. And over time, we would evolve the schema as new actors are added or smart contracts are added. And we would ideally encourage others to adopt a similar pattern, because now your software produces a pile of data that by inspection, you can understand how to parse the innards of. That's the direction we're looking. I haven't seen much in the blockchain space for holding data that comes out of it.
I think Coinbase has a project called Rosetta that integrates with a bunch of blockchains. I'm not sure which ones that try to extract some of the JSON RPC data from there. So you will integrate with Rosetta, and perhaps if you do the mapping between Rosetta and your blockchain using the JSON RPC, you can perhaps get the information you want. I'm not sure about the details though.
Okay, thanks.
I have a question. It's sort of slightly related to the FEM question, what happens when the FK adds a bunch more data, but also just if you look at what the network growth team is saying about like the growth of all the data they're going to be onboarding, have you done anything about what that means for the growth of the chain and then the impact on Lily? Because it feels like these things may be combinatorially accelerating.
Yes. My hope is what the data team was talking about with the growth is that's deals don't live on chain, they live off chain. They're in sectors, they're in the miners. The current size of one state tree is about 75 gigabytes. Additional state trees aren't 75 gigabytes because it's just a change. It's the IPLD objects that have changed to produce the new state tree. It's about 5 or 6 megabytes last I checked. The FVM will certainly add a lot more. Actor state is user-defined smart contracts are deployed onto the chain, and more actors that people create are added. It's a little early to tell. There is the Wallaby testnet, which Lily runs on. Ultimately, I expect most data to remain off-chain. It's something we basically have to watch and react to. At the current time, it's a little bit hard. I hope that answered the question somewhat.
So one of the big issues with like blockchain explorers and tools that do blockchain logs is you introduce this trust problem where I have to trust you that the logs that you're giving me are accurate. So you're doing a one-way transformation. Is there anything in your scope that could do the reverse as well? Like, are you collecting enough of the data on the chain to be able to recompose the IPLD structure to rehash to prove that you've got like transactions or blocks that you're looking at are correct? So
right now, the CSV and the Postgres exporting is what the data comes out of Lily is. It goes in the Postgres or it goes in the CSV. So it would be challenging to reconstruct a message from that. The new model we're moving towards, which uses IPLD to contain the data, will extract the entire message and some metadata on top of that. So in theory, yes, you could scan this model and validate that it contains the pieces of information that are on the chain. I think a second way to approach that is to define a specification for implementers of software like Lily to follow, and then do the thing separately and compare the output you get. And if you get similar information or the same Merkle-DAG root, ideally, then you would have some verification that you've at least either made the same mistake or done it the right way.
Right. So your IPLD export would be the IPLD chain original plus also whatever indexing, layering that you're putting on top of it?
Mostly, yes. Yeah, not everything. Otherwise, it's basically a snapshot at that point. But like sectors are an example. Like we extract the entire sector and then metadata around that. So you could create a CID of the sector, validate that exists on chain at that point in time, and move on your way. It's a great question. Thank you.